convergence. Okay? Okay, so we've kind of seen the power series. It's when we're going to have x's and n's going on. We've talked about that, right? So that's the power series. So when a power series, whenever you're looking at these terms and you see an x minus something, you can go and you can pick out where it's centered, even if it doesn't tell you. So if this had x minus 5 going on the whole time, then where is it centered? At 5. If it had x plus 5 going on everywhere, where is it going to be centered? Negative 5. Okay, so you can always tell where it's centered by that. And if you don't see the plus or minus going on, you know it's centered where? And what's that called? Florin. Okay. Alright, so here you can just see, here's one that's centered at negative 1. Here's one that's centered at 1. Okay? So that's something you're going to have to identify as where is it centered. Alright, so one of these three things can happen. You could be centered at C and it's only going to converge at C. So it just converges at C. Or it could converge for some radius. Or it can converge everywhere. So those are the three things that could happen. So this R right here is called the radius of convergence. So if I had some function and I centered it here at C, and I could find a polynomial that went from here to here, and let's say that that radius went out 2 in both directions, then your radius of convergence would be 2. Okay? I kind of think of it like if you draw a circle, you can make the radius. Okay? So it really makes sense. Alright, so these just correspond, one with 1 and 2 and 2. In my notes, I just kind of made little arrows. 1 goes with 1, 2 goes with 2. So if it just converges at C, it's only going to converge at that point. So it's just a point. And if you have that radius of convergence, you're going to have an interval. And if it converges everywhere, then your interval, if you had to do an interval, it'd be like from negative infinity to infinity, because your radius of convergence would go out infinite length. Okay, so it'd be all the x's, the real number line for x's. But if it's an interval, you could write it like that. Okay, what would you write? Okay, are you ready to see some now? Enough talking? Alright. Alright, so find the radius of convergence for the following series. Using this series, what do you think to try to see if it converges? Okay, the ratio or the nth root. Both of those would be good, okay? Both are great. Personally, both of those are great. I always just normally go to the ratio, okay? But both of those sound great. You could use either one. So let's say we wanted to try the ratio. If you want to try the nth root, you can as well, okay? So there's multiple ways to do stuff. So let's say we set the ratio. Set up the ratio in your group. See what you can remember. Or if you want to do the nth root, set up the nth root in your group. And you might want to get out your little flippies, because you've had a little bit of a break, right? So you might want to get out all the conditions for what happens when. guys agree that at plus 1 I could just pull out the 2x? Well, whenever I see that plus 1, I just normally just do that. If it was plus 2, then I'd write it with a square. Alright, anyway. No, I'm not. Gosh, Lane. Alright. Alright, so this is going to be the absolute value of what? 2x. Let's say that we had done the nth root. Okay, I'm just kind of going back. If I had done the nth root, I'm going to take the limit as I go to infinity, the absolute value of the nth root of 2x to the n, right? And again, what do you get out? Absolute value of 2x. So either way, you would be fine if you saw either one of those. What are the conditions for both of these are the same? What's the conditions for convergence? What's that?
Absolutely converges if it's less than 1.
For both of these, right? So I know that it's going to absolutely converge when the absolute value of 2x is less than 1. So now basically we're just going to go and solve for x. Well, we've got the limit part. Okay? So that is the limit part. And when you solve, let's see, that would be, or actually solve for the absolute value of x, sorry. Sorry about that. So the absolute value of x is less than what? 1/2. Whichever way you want to do it, right? The root or the ratio. Mason.
I thought you like plug in infinity after you get the absolute value of 2x, then you're like, oh, that's great.
Okay, that's a really good observation. What is this doing?
Oh,
so we're only doing it at the ends, and this is x. Okay? No, that's a really good point, Mason. Thank you. I should have stressed that more. All right. Don't chill Tyler like that. So what is your radius of convergence now? What is it? Your radius of convergence is 1/2. Where are you centered? Yeah. Right. What do you think? So you're going to do like for what the x is. So these are your x's. So here you can see that radius of convergence is 1/2. Hey, just counters. You got a lot to do today. How's your time today? Sorry. All right. So, little question. Do you know if it converges at the endpoints here?
No.
What happens when it equals 1/2? That means it would equal 1, right? It would be inconclusive. All right, so we're just going to think about that, but we're going to do another one. Do this one with your group. Find the radius of convergence. Just look at the x. The x is just going to go along for the ride. Okay. let's just talk about those. Look at your flip charts. What are some tests where we can find conditions where it converges or diverges? Okay, so the end group.
Ratio.
The ratio. Anything else that tells us that condition?
No.
Well, the alternating series test would tell us just like if it converges or if it diverges. It doesn't really have that condition part, right? Right. Okay, so you could kind of think like that. Yeah. These are the ones you're almost always going to use. I'm going to tell you this one will almost always work for you. On the AP test, you guys, on the AP test, the ratio is used most often in the free response. Actually, I don't know if anything else is really hardly ever used for one of these. Okay? Now, that doesn't mean you can't use the nth root when appropriate. And in this one, you could definitely use either way, right? Okay, so I'm going to go ahead and just set up the ratio, because I favor that one, since it happens more frequently. Okay, so the limit, so we go to infinity. Do I even have to worry about the negative 1 to the n when I take the absolute value? So, Shane, I'm going to skip. This would be x times x to the n over 2 times 2 to the n times, I did it? Oh, 2 to the n over x to the n, right? When it's n plus 1, I'm just going to go ahead and pull it out.
No, I was wondering about the one.
Now, oh gosh, as I go to infinity, x goes to infinity, so this is infinity, right?
No.
No, because this is... Alright, so this is... Whoa, what just happened? Alright, well that was equal to this. So what do you get for your radius of convergence? This is going to have to be what? Less than 1 to converge. To absolutely converge. So x has to be, the absolute value of x has to be less than 2. So your radius of convergence is 2. Where are you centered?
0.
So if I'm centered at 0 and I'm going to go out to 2 and negative 2, I can see my radius of convergence here is 2. Do I know if it converges at the endpoints yet? No, because that test is inclusive. It's inclusive at 1. Okay, so when it says find the interval of convergence, and those tests are inconclusive at 1, if I was to go set up an interval, I would have to say something like this, but I don't know if they converge or diverge at negative 2 and 2. Okay, do you have a question?
No, I got it.
Thanks. Alright, so I don't know what's happening here at 2 or negative 2. So I'm going to go have to check those endpoints separately. Okay, so this gets into a lot of work and a lot of remembering all those series now. So first things first, find the radius of convergence. Even when it says find the interval, first go find the radius. Just like what we were doing. So do that first. And don't write too big.
Oh.
confused about this limit? So here I'm looking at the ends. Are the ends bigger on top, bigger on bottom, or the same? The same. So I'm going to take the coefficients. Does that make sense? So my coefficients here would be x over 1, which is x. Absolute value still. Okay. So here I know that this is going to converge absolutely when the absolute value of x is less than 1. So I know that my radius of convergence is 1. I'm centered at 0. So now let's go ahead and do my endpoints. Back to algebra 1. What would this be? Negative 1 and 1, but I don't know what happens here because that test fails at 1. Okay? So first get your radius of convergence. Second, set up your interval with your question marks. Okay? Third thing you're going to go do is check both endpoints. Into the original series. Yes, I do. All right. Anybody need this longer? I'm going to erase it. So we're going to plug those into x, and then we're going to see what happens from all those tests that we learned. So then it doesn't look like a power series anymore. It will just look like a regular old series because I've got rid of the x's and I just have n's. So which x do you want to do first? Lindy, which x first? All right. Let's do negative 1 first. So everywhere I see an x, I'm going to put in negative 1. Then simplify it. Got negative 1 and negative 1, so what can I put that to? 2n plus 1. Is it okay if I don't write the n equals 0 and infinity every time? No? Okay. All right.
I know, really.
What? Okay, so that would be negative 1 to the 2n plus 1, which would just end up being what? What's negative 1 to the 2n? So that's like negative 1 to the 2n times negative 1 to the first, right? And negative 1 to the 2n, I think I heard it over here. Courtney, did you say it? 1. Because it's going to be squared, right? So negative 1 squared is 1, and 1 to the n is 1. So that just becomes 1. So all you're left with is negative 1. So everybody at your group has a question so far. All right. So what's going to happen here? The limit as I go to infinity of negative n minus 1 equals what? Negative infinity, which does not equal 0. So this diverges by the term. Do you have to state the test? Yes. All right. See how this problem is going to be worth a lot of points?
Thanks.
All right. So I know that this one just less than. It is not less than or equal to. So I can get rid of the question mark and say it is just less than that. Now go try 1. So do you even care about 1 to the n? Nope, that's just 1. So what test do you want to use? Let's use the alternating series. I hope, wow, we picked up over here in the microphone. Well, I was recording because I knew that you'd be here, and then I thought, well, I might as well in case people are absent. Alright, alternating series test. The limit as n goes to infinity, do I put absolute values, Nate? No, I do not. So all I'm going to do is drop off the alternating part and write an n plus 1, and what do we get out, Nate? Infinity, which is not 0, so what does it do? Diverges. Okay, by the nth term. So in this case, now I can get rid of this and just keep it less than.
I thought we were using alternating series.
We were, but in the alternating series, this ended up becoming an nth term. Okay? So, final answer. They're both left off. All of that work, right? Just to see if they had lines underneath it. That's perfectly stated, yes. Alright. So, if it says interval of convergence, you got a lot of work to do. Unless, right? Unless, and you notice how you have some space up above to write? So we're going to write this part. Unless you have a geometric series. Why? Look it up. Look it up on your little flippies or in your notes, wherever. Because on these guys, when it equals 1, so here endpoints are inconclusive, right? But what about the geometric series? Right, when you know here the endpoints have to do what? When it equals 1, it's going to diverge, always, okay? So if you want to kind of put this in, nth root ratio, you're going to have to go check all of those intervals of convergence, but if it's set up as a geometric series, which we will get to, okay, probably not today, but in the future, so you know this, you do not have to check your endpoints because they always diverge. And that's, you're like, yay, if you like realize that as you're doing it. Sometimes you're like, oh, how didn't I realize that? I did all this work. Okay? So write that up there somewhere, like, make sure you know those things. And then in your group, try the next one. What? Right. Whatever those endpoints are. So they'll never be included. And right now what we're doing is the main reason why you learned all of those tests. Just for this, yeah.
So I got rid of
I'm pretty bad at capacity as a teacher.
If you want to get up. If you want to check and see if you have the right radius of convergence first, you should check before you move on. Yes. Are you serious?
True story. You can get ties for like $2. You can see best for like 5. You can get a full seat for like a shop does.
Okay, keep going. I mean, focus. Focus. Focus.
There's a lot of it.
I know I bored you. Oh, you're fine. You're gonna have to stay. I'm supposed to go to a concert. No. Let's go, let's go. Get this one done. I'll tell you later. Did everybody get the radius to be 1?
Yeah.
Sit for that 0.
Yeah.
Okay. I told you how to write.
So there is no shortcut. Like, it's not there. Make sure you
Yes, all of that was if you want to do so see if you got it to simplify what I've got up here.
Or just
Well, yeah.
it's negative 1 so negative 1 squared.
That's negative.
Or is that 1 over into it's bigger on the bottom, smaller. Series. So it's bigger.
Do you guys do a direct comparison or a limit comparison or both?
Direct.
Okay. Anybody do a limit? It's negative 1 to the n. Sorry. All right, sorry.
It's one time.
Now, next one we can
I don't know. I don't know. I haven't blitzed. After we're done with the sewing, we'll decide. It's gonna keep the same order. All right. So, would you guys get this guy converged by either direct comparison or limit comparison? Okay, I don't care which one you use. And what did this one do? Did you do alternating series?
I did alternating.
All right, I would do alternating series. So let's see then. The limit as n goes to infinity. 1 over n plus 1 over n plus 2 equals 0. So we're good so far. And then what do I have to do? Take the derivative? I'm gonna cheat. I already got it done.
This one of those where you can just show that it's so n is greater than equal to plus 1.
Yes, you could do that as well. To show that it's decreasing, or you could do the derivative. I'm fine either way. So it's decreasing, so this tells us it does what? Converges by the alternating series test. So final answer, am I going too fast? Right. Would be -1, and now both of them are included. So do you think both have to be included and both have to be not included? Like either or? Or do you think you could have combinations? Oh, there's combinations, yes. Okay, deep breath in. Out. ready?
Superman. Oh,
I don't. I thought I did.
Oh, I thought you were just joking around. Like, he obviously doesn't know.
Okay. Okay. How am I? Whatever I want. Minutes left. So, ready?
yeah.
You can take the derivatives and the anti-derivatives of a power series. Tell your neighbors that. Come out. Okay. Now, notes are pretty time consuming, and if we want to talk about this more in detail later, we can. But when you take the antiderivative, you know how you always have plus C? Okay. Alright. It's always going to be 0. Okay? Yeah. It's always going to be 0.
Find a counterexample.
So,
Big C. Big C's gonna be 0.
we don't have to talk about it. We've got a lot going on today. If you want to talk about it later, we can. Okay? But just trust me. It's always going to be 0.
Is there another reason it's in the front?
No. Okay.
Yes.
So, when you take the derivative, you're going to derive with respect to n. Alright? So we're going to take the derivative with respect to n. So like the n's, or sorry, with respect to x, and n's are like the numbers. Sorry, I just said that wrong. With respect
Like,
to x. So you're going to like, n's are going to be kind of like a number here. So if you had it raised to the n and you take the derivative, then you do n minus 1, right? Bring your n down and do n minus 1. If you had the antiderivative, you're going to do n plus 1 and you're going to divide by n plus 1. So it's just like the basic power derivatives and antiderivatives. Okay, so with respect to x, I can't believe I just said that. Now, this is the kicker too that you want to star. When you take the derivative, you jump ahead to 1.
We talk about that after class 2.
Yeah. Okay. These are all like, when you get to real analysis, you can talk about it actually. Alright. Alright. So, when you take the derivative, star that, circle that, you jump ahead to 1. Hope you don't miss that. You ready for the easy part though?
Yeah.
Okay. The radius of convergence will always be the same for the derivatives and the antiderivatives. Did I say the interval?
No.
I said the radius. So you can set up the radius the same, but you still have to go check the endpoints. Go write that in however you need to. Alright? So the radius for the derivatives and the antiderivatives is going to be the same, but you're still going to have to go check the endpoints. It's still going to be centered in the same spot. Everything will be set up the same except for the endpoints. It could be the same. We don't know. They're not guaranteed to be the same. Are you hanging in there?
It's not just like it's like Monday after Wednesday weekend, switch weekends. 2 days before that, another morning, and it's just like.
And it's like the hardest section. Longest section, I should say. Alright. So it wants us to find the intervals of convergence for f of x, f prime of x, and the integral of f of x. We're not going to do every single one of these, okay? That would take a long time right now. Let's first off go write what f prime of x and the integral of f of x would be. Let's do that first. Okay, f of x is just given, right? So we're going to take a derivative, right?
Yeah, we are.
All right. First off, if I take a derivative, what do I put here?
So figure it out.
Is it still 0?
Oh, n equals 1.
Okay, jumps ahead.
Yeah. Remember Fox though.
Okay. You want to write, Mason?
Oh, shit.
Okay. So now I'm still going to have, this is like the coefficient. It goes along for the ride. So circle that part that I said is the coefficient.
That part.
Coefficients go along for the ride. What else is part of the coefficient? So circle it. No? Yes! Okay. So all that he circled is part of a coefficient. Because we're assuming n is some number, right? So coefficients are going along for the ride. Go put them down first. They went along for the ride. So just rewrite them. Don't worry about anything else yet. Just put the coefficients that go along for the ride. Make sure you have parentheses. All right. It's doing great. Good.
You're doing really well.
All right. So coefficients came along for the ride. Now we're going to take the derivative of this part. See how it has the x? So let's use another color. All right. So kind of box that in or circle that. Right there, that's the only part with x's. So that's the part we're going to derive. So how do you derive? Perfect. Now write it in series. So put that in.
So just times twice.
Good.
Yeah, makes sense.
Okay. I'll let you go get that down. Is that okay? Now do the antiderivative in your group. So you can do the antiderivative now. No, that's just coefficients go along for the ride when you derive or take the antiderivative. I teach that. I have a really funny picture that goes it's these folks like on a roller coaster. Anyway, it makes you always remember that. Alright. So again, my coefficient part that Mason has circled in red is going to come along for the ride. Alright, so then I'm going to have to do what? X minus 5 raised to the n plus 1 all divided by n plus 1. Find the radius of convergence. Which one do you have to pick? Will it matter?
Shouldn't.
It won't matter. They will all give you the same radius of convergence. So you guys decide, find the radius of convergence.
Which one do you guys get? That's what I was. Okay.
I'm using the original, and I'm going to use the ratio. Do you agree that you cannot use the nth root here? Yeah, those are not, that one's not raised to the nth root, right? All right. So I'm going to do the ratio. Oops. This was the first one. So I rewrite that. X minus 5. Bigger on top, bigger on bottom, or the same? The same. So I have to take that coefficient. So I have still the limit. It goes to there.
Putting on the top x minus 5 times
N.
n.
So now x,
I have my
Yeah, because now this is respect to n, whereas derivatives will respect to x. Woo, right? Okay. So it's going to converge when that guy is less than 1. So, let's see. My radius of convergence, that's going to go to x minus 5 is less than 5. So I'm centered at
5.
5, and my radius of convergence is at 5.
Uh-oh.
Is that all right? So you're centered at 5, and your radius of convergence is 5. So if you were going to go set up the whole x part, right, what would that be? 0 to 10. Is that okay? All right. If we have a snow day tomorrow, when we have a snow day tomorrow, I want you to go find if those are included or not included for all 3. Write that down. That's part of your homework, in addition to your homework. All right. Oh, if you take the derivative, it always goes to 1. The antiderivative stays to 0. Right.
Listen, you can use
Okay. One more thing. You guys are doing great. One more thing. Sorry about this. Hey, ready?
Listen, Mr. Rose.
All right. Thank you, sir. All right. One more thing. You are going to have to know. Does anybody have your book on you? Okay. Page. Let me look it up. It's at the end of this. Oh. There's basic ones that you need to know, like the e to the x. You need to know that polynomial, that Taylor polynomial, very quickly. There's e to the x, sine x, ln of x, finding them. Okay, page, write this down in your book. Page 638. Know these. Okay? And I'll come around and show you. See right here? See right here? Oh, yeah.
Are these just random?
No. Sine, cosine, arctan,
Natural
e to
one,
the
second,
x. I don't know about arc sine, but You could always take the time to find it. You can. But on the AP test, you're going to need to just, like, that time is so precious, okay? If you just know these, it will make your life so much easier. So if you can get flashcards, whatever, like, see the patterns with the sine, the cosine, the arctan, and we'll talk about it more as we move along, okay? But really start to look on those as well, so that you can start to know them. So, for instance, let's say that right here it says find the third degree Taylor series centered at 3 for e to the 2x. Alright? So the first thing you'd want to do is start with the basic of e to the x. So if you looked in here, e to the x, one that you would have memorized, where'd my notes go? E to the x is always going to be positive. Okay? This is what e to the x is.
AP's okay with this, just use this.
Oh yeah, they want you to. Alright? Because what they want you now to do is, and we'll practice this in a lot more depth later, but they want you to be able to manipulate these. And this will help you for that Lagrange error bound stuff that you have. Okay? So e to the 2x then, instead of having an x, what are you going to go plug in? A 2x. So everywhere you see an x, you can go plug in a 2x. Oh, sorry. I wanted that to be centered at 0. Sorry. We're not going to make it too difficult. All right. So 1 plus 2x plus 2x squared over 2 factorial plus 2x cubed over 3 factorial plus 2x to the n over factorial.
If we wanted to center at 3, would it be the parentheses on it, but minus 3?
Yeah, it's a little bit different. Okay, so just, all right. So if I wanted to find the power series, what would all of that equal? Can you write that as the series now? So let's see, I'm going to start at 0 to infinity. And basically, you've already got it here. We've got 2x to the n over n factorial. And then if they wanted you to derive it, you could. Let's do the derivative. So we're going to derive with respect to x. Change it to 1.
Good.
And you might rewrite this as 2 to the n, x to the n over n factorial. So then you could definitely see your coefficient going along for the ride. No, that's just part of the derivative part. Yeah. So I'm going to still just have this part going along for the ride. And then I'm going to derive this part right here. So it's going to be n x to the n minus 1. And if you wanted to simplify that, you could. Let's see, that could be 2 to the n x to the n minus 1 over. How would that cancel? N minus 1 factorial, right?
Yeah.
You could pull out an n here and cancel. You could do other things, but. What do you think? Okay? So you're going to do a lot with this manipulation. It's getting to know e to the x, sine x, cosine of x, arctan of x, ln of x. Those are the basic 4, okay, that you really, really need to know. All right, that was a long part of your day.
That's all we're doing. Let's just finish up that.
Okay, so you have your homework, which is 8-8, and then I want you to finish up the part in the notes. I want you to finish working on the garage. I'm writing all this down. Okay, stop this.